Welcome back. In this video, we're going to try to show that the integral of f of sine of x dx between 0 and pi over 2 is the same as the integral of f of the cosine of x dx between 0 and pi over 2. And after that, we're going to try to compute the value of the sine square dx between 0 and pi over 2 and the value of the cosine square between 0 and pi over 2. If you want to try this problem, try to use the relationships between cosine pi over 2 plus x and cosine of pi over 2 minus x. Okay, try for instance to let y be pi over 2 plus x and see if that works. And after that, try to let y to be pi over 2 minus x. This will help you solve this problem. Okay, let's solve it now. So if I try to let y to be pi over 2 plus x, this one will not work. You will see why. Or you can see that by yourself, because we don't know f of the minus sine of x. We don't know that. We don't know what happens with that minus. We don't know how we can go back to f with the minus inside. So instead, we're going to let y to be pi over 2 minus x. This one will give us that dy is minus dx. Okay, this is the first step. And after that, when x is pi over 2, y is 0. And when x is 0, y is pi over 2. So when x is 0, we have this. And when x is pi over 2, we have y is 0. Okay, we have this result now. We can go here and plug these values here. Okay, we can start from this one here. Okay, I'm going to use this variable here in this expression and show that this one is the same as this. Okay, you can also use the relationship between sine of x plus pi over 2 or sine of x minus pi over 2 and bring this one to cosine. Okay, I'm going to start from here. Okay, so here I have the integral between 0 and pi over 2 of f of cosine x dx. Now, if I let y to be pi over 2 minus x, that means x is going to be pi over 2 minus y. Okay, so I said when x is 0, y is pi over 2. When x is pi over 2, y is 0. And I have f of the cosine of x. X in this case is going to be pi over 2 minus y. And dx is minus dy. Okay, note here that to get the x, I have to multiply by a minus sign and bring the pi over 2 in this side. Okay, now I can use the minus to flip the bounds of this integral. Okay, the minus sign here is going to let me flip the bounds. So the integral between 0 and pi over 2 of the cosine of pi over 2 minus y. What's the cosine of pi over 2 minus y? This is just sine of y. Okay, so therefore I have f of the sine of y dy. And since y or x is just a dummy variable, I can put this one in this form. F of sine x dx. Okay, this will tell me that I have shown that this integral on the right is the same as the integral on the left. And that's what I need in this case. Okay, so this is starting from here. I get back to here. I showed this one is the same as this. Okay, using this relationship. Remember here how we get this y and x. We can write it in general that the cosine of a minus b is cosine of a times cosine of b plus sine of a sine of b. And if you have a plus, you just switch the plus to minus, or you have a minus, you switch to plus. This one helped me here in finding this value here. And remember that the cosine of pi over 2 is 0. Okay, now we can use this result here. We showed this result. We can use it to find these values here. What's our f in this case? What's f? Okay, what's our f here? Clearly the f is x squared. okay? Because if we have f of x is x squared, what's f of the sine of x? It's going to be sine squared of x. And what's f of the cosine of x? It's going to be cosine squared of x. Okay, therefore I have my f is the x squared. Okay, since I have that, now I can compute the value of the integral of sine squared dx, which is equal to the value of the integral of the cosine squared of x dx, using f of x as x squared and remembering this result we just proved. These two integrals are the same. Okay, now since these two are the same, we can use the fact that the cosine squared or sine squared of x, the cosine squared of x is 1 minus sine squared of x. You can also use that sine squared of x is 1 minus cosine squared of x. If I use that, I'm going to put it here, and therefore I have the integral between 0 and pi over 2 sine squared of x dx is the integral between 0 and pi over 2 of 1 minus sine squared of x dx. I'm going to bring sine squared of x to the other side. Okay, I'm going to have 2, the integral, let me do it here, it's going to be the integral between 0 and pi over 2 of sine squared of x dx is going to be the integral between 0 and pi over 2 of 1 dx, which is pi over 2. Therefore, the integral between 0 and pi over 2 of sine squared of x dx is pi over 4. I divide both sides by 2. And the same, this is the same as the integral between 0 and pi over 2 of cosine squared of dx. Okay, therefore, the value, these two are equal, and they both equal pi over 4. Okay, and this is what I need. This is the result that I need. Note here that I have used that f to get here. F is x squared. Okay, I have used the change of variable using these two, or just this one. Try to use this one here, and you're gonna see that you're stuck with a minus sign, and therefore you can't proceed. Also, if you want to start from here, try to use the values sine pi over 2 plus x or sine pi over 2 minus x. This is a learning experience, and you're gonna see get stuck with a minus 2. You can start from here, and you can get to this result here. And after that, you notice that if you take f as x squared, you will see that this will make these two integral the same. And after that, you can use that if we let cosine squared as 1 minus sine squared of x, and you can solve. Also, if you want to use sine squared of x as 1 minus cosine squared of x, you can also solve the problem. Okay, so this is a simple but some techniques problem, and the technical problem that we need to solve, and we need to know how to solve when we deal with this kind of integrals. Okay, if you see any errors or mistakes, please let me know. Thank you very much.